So the topic 2 is about the atomic structure and the periodic table. As we know, when we compare what we know about the atom, the central part of an atom is known as the nucleus. And inside the nucleus, there are subatomic particles, which are known as protons and neutrons. So proton we can represent by a small p, and neutrons we can represent by n. Around the nucleus, there are particles which are revolving around the nucleus, and these particles are known as electrons. So around the nucleus, you have particles such as electrons. So if you find, or you want to find the neutron number, proton number, and electron number, so one thing which we call, that's known as the mass number, which is represented by A. So mass number is sum of neutron and proton, where Z refers to atomic number, which is simply known as the number of proton. So in this example, it contained 2 protons. So Z is equals to 2. And it also contained 2 neutrons, so sum of proton and neutron. So A is equals to 2 and Z is also equals to 2. Sorry, neutron equal to 2 and proton equal to 2. So the mass number is equals to 4. And because this atom is having an equal number of protons and electrons, as we know, protons are positively charged and electrons are negatively charged. So this is an atom with no charge or no net charge. So resultant will be 0, or resultant charge will be 0 because the proton and electron have the same charge. So when we say, so electron number will be same as proton number for a neutral atom. Now when we compare the relative mass and relative charge, what is the meaning of relative? It's just a comparison, the ratio. So actual mass of a proton, when we compare mass of proton with mass of neutron and with mass of electron. So mass of proton is 1.6 into 10 to the power minus 27 kilogram. Mass of neutron is also 1.6 into 10 to the power minus 27 kilogram. And whereas mass of electron is 9.11 into 10 to the power minus 31 kg. This is the actual masses. But when we take the simplest ratio, how to take a simplest ratio? So when we divide all of them by 1.6 exponent minus 27, so the simplest ratio so this will be 1, this will be 1, and this will be 1 divided by 1840. When you divide all of them by 1.6 exponent minus 27 kilogram. So the simplest ratio is 1, 1 and 1 divided by 1840. If you round it off to a nearest 1000, like 100, so it will become 1 divided by 1800. That's why when you take a relative mass is not the actual mass, it's just a ratio of the masses. So proton, for a proton, neutron, because they have the same mass, so ratio is 1:1. But electron is much lighter. The ratio is about 1 divided by 1840. And the position where we find this proton is inside the nucleus, neutron is also inside the nucleus, but electron is revolving around the nucleus in a shell, or we call that as orbital. Orbit or orbital. You will learn a difference between the orbit and orbital in this chapter. Then when we compare the relative charge again, it means the ratio of the charge. Actual charge, for example, for a proton, the charge of a proton, charge of neutron and electron. The charge of proton is plus 1.6 into 10 to the power minus 19 of the coulombs. Neutron overall it's neutral, so zero charge, and electron is 1.6 into 10 to the power minus 19 coulombs as well. But the only difference, proton is positively charged where electron is negatively charged. So when you take the simplest ratio, you divide by 1.6 exponent minus 19. So this will come out plus 1, this will be 0, and this is minus 1. So you can see proton is plus 1, neutron is 0, and electron is minus 1. So this is not the actual charge, it is a relative charge or comparison of the charge. The actual charge of a proton is 1.6 exponent minus 19. For electron is minus 1.6 exponent minus 19. But when you take a simplest ratio, the simplest ratio is 1:1. That's why you get the same charge, but because their natures are opposite, so if one of them is positive, the other one will be negative. Is it clear? Any doubt in this? Then for an element, so for an element, the big number is representing a mass number and small number is representing the atomic number. Mass number is denoted by A and atomic number is denoted by Z, where A is the sum of neutron and protons and Z is the number of the protons, total number of protons which are present. So if in case of in this example, like lithium is 7 and 3. So if we need neutron number, so how to get a neutron number? It is A minus Z. How to get proton number? That's equal to Z. And how to get electron number? Electron number vary. If it's a neutral atom, then proton number is same as electron number. But if it is not a neutral atom, if it's an ion, positive or negative, so the formula is Z minus the charge. So charge can be positive, charge can be negative. So example, if the same example, if I change that this was a plus charge. So if I need neutron number, it is A minus Z, which is 7 minus 3. That's equal to 4. Proton number is same as Z, which is equals to 3. And electron number is Z minus the charge. So Z is 3 minus, what is the charge here? The charge is 1 plus or plus 1. So 3 minus 1, so number of electrons will be 2. And if it's a positive ion, positive ions will have more protons as compared to electron. If it's a negative ion, it will have more electrons than proton. And if it's a neutral atom, means there is no charge, it means it has equal number of proton and electrons. Is it clear, this part? The atomic structure, the charge on the ions. Then isotopes, how we define isotope? So isotopes are atoms with the same number of proton but different number of neutrons. We simply call them as isotopes. You have to learn these definitions you will find a question in which you have to define certain terms. So atoms which are having same proton number but different neutron number, or same atomic number but different atomic mass, are refers to isotopes. So example, if we have hydrogen 1 1, hydrogen 2 1, and hydrogen 3 1, we call these as isotopes of hydrogen. Why? Because they have same atomic number but different atomic mass. Atomic mass is, or mass number is Z, A, sorry, and atomic number is Z. So for the first one, A is equals to 1. For the second one, A is equals to 2. And the third one, A is equals to 3. But they all have the same atomic number. You can see that's 1. So if I need neutron number, it's A minus Z. So when I subtract this, this will be 0, this will be 1, and this will be 2. If I find proton number, that's equal to, so A minus Z will give us the neutron number, and proton number is same as Z, so that's equal to 1. This one also equal to 1, and the final one is 1. So they have same atomic number, but they have different atomic masses. So what we call them as isotope, or they have same proton number but different neutron number. Also we call them as isotope. Then when we compare the mass, we call that as a relative atomic mass. What is the definition of relative atomic mass? Relative atomic mass, or relative isotopic, first relative atomic mass and then relative isotopic mass. So what is relative atomic mass? So relative atomic mass is average mass of an atom compared to the 12th part of carbon 12, or compared to the 12th of a mass of one atom of carbon 12. What does it mean? This is a standard definition. So example, as we know, the mass of the carbon is 12. This is just a theory. In practical, it's not like this. It's not done like this. This is just a theory. So we know the carbon mass is 12. So if I divide this into 12 parts, so I divide into 12 parts. So what is the mass of each part? The mass of each part is 1. So what we do here, we just compare. We compare this with unknown element. Like example, any unknown element you discovered, say element X is discovered. And you want to find the mass of this unknown element. So this is just again a theory. It's not practically done in this manner. This is a theoretical definition of relative atomic mass. Why we call relative? Because it's comparison, it's compared to carbon. That's why we call that as relative. So example, if 3 units of a carbon are balancing this. So if 3 units of a carbon are balancing this, and we know the mass of each unit, is 1. So what is the mass of this substance X? So mass of this substance X is equals to 3. So average, the definition is, it is relative atomic mass is average mass of an atom compared to 1/12 of the mass of one atom of carbon 12. Is it clear? Relative atomic mass when you are comparing atom, and it's a molecular mass if it's a molecular. Example, When I say sodium, sodium is in at Na. So means it will have RAM, relative atomic mass. But if I say oxygen, how oxygen exists? Oxygen molecule exists as O2, then it will be relative molecular mass. So how we represent molecular mass, relative molecular mass, capital M and small r. Relative atomic mass, capital A and small r. So for atom, it's called atomic mass, and for molecule, it is called molecular mass. Is it clear, the idea? This is just a theoretical definition which explain the relative atomic mass and relative molecular mass. Any doubt in this? Then relative isotopic mass, it's a mass of isotope which we compare with a 12th part or 1/12 of the mass of one atom of carbon 12. Why specifically carbon 12 is written? Because carbon itself can have isotope carbon 12 and carbon 14. So when we have a carbon 12 and we divide this into 12 equal parts, then mass of the one part is called 1 unit. And how many units are balancing with the other substance? That is simply known as relative isotopic mass. Now, this is a theory, but practically how you can find a relative atomic mass or relative molecular mass or relative isotopic mass, that's done by a device. That device is called a mass spectrometer. So practically you use a mass spectrometer to identify or to find the atomic mass or molecular mass, or you can also find the number of isotopes. How it is done or how we use it. So example, first what we do, say an unknown element X is there, you discovered an unknown element X and you want to find its atomic mass. This is a practical way of finding the atomic mass, not the theoretical. That's a definition what I discussed in the previous slide, but this is a practical way of identifying or finding the atomic mass. So first what we will do, say an unknown element X is there. It can be solid, liquid or gas. If it is a solid or liquid, so what we will do, first we will vaporize. Like example, if this substance X is in a solid state, we supply enough energy so that we can vaporize. So this element X will now convert into vapor or it will convert into gas. Maybe naturally the element X exists as, it can be a molecule, but what we do, or it can be an atom, but the state is solid, example. So first what we did, we vaporized the sample. How we vaporize the sample? By supplying a heat energy. So when we supply the heat energy, the sample will be vaporized. Then what we do, we ionize the sample. How we ionize the sample? Like example, if this was an atom of element X, so we use a fast moving electron. We use a fast moving electron to knock out the electron from the atom. So if this electron hits the electron inside the atom, so this X will lose that electron, or there's a loss of electron. So as this X will lose electron, what will be the charge? Because X lost electron, So the charge on the X due to loss of electron will be positive. And there are two electrons. Why there are two electrons? Why not one electron? Because the one which you use and the one which is released. So first you vaporize a sample. Why you vaporize a sample? So that it can move. A solid cannot flow. Liquid and gases can flow. So that's why we vaporize the sample so it can move easily. Then we knock out the electron from the sample so that it will become a charge. As it become a charge, so what we will do, as it is a charge, so the element X is now in a gaseous form and it is charged. It will always be a positive charge. It cannot be a negative charge, even though it's a non-metal. Metal is there or non-metal is there. In the mass spectrometer, all will get a positive charge. Why? Because we knock out the electron from them. That's why they all will get a positive charge. So now it get a positive charge. Then what we will do? We will use electric field to accelerate this. So electric field is there as negative terminal of electric field. So this negative terminal will attract, and as it will attract, it will move and pass through this and make a beam. And then what we do, we use a magnetic field in the region. The magnetic field, in physics you studied. What is the purpose of the magnetic field? Magnetic field can deflect the charge. Electric field can accelerate the charge. The magnetic field can deflect the charge, where electric field can accelerate the charge. So what happened due to the magnetic field? This will deviate or deflect. And when it will deflect, we have a graph here. On x-axis, we have mass and charge. And on y-axis, we have relative abundance. So example, this is a mass to charge ratio. So this element hit the mass to charge ratio at a point of 40. So what is the mass of this element? How we can identify the mass of this element? So as we know, mass divided by charge is equals to 40. So what is the charge? As we remove one electron, so charge is plus 1. So charge is plus 1 is equals to 40. Plus 1 is multiplied there. So mass, what is the actual mass of this atom? The actual mass of this atom is equals to 40 atomic mass unit, or 40 AMU. So using this, we can identify the atomic mass of a substance. This is a practical way of finding the atomic mass of unknown element. Is it clear, the idea? This is just an overview. I will explain all the points, but this is just an overview of this. So what happened, like now you can see here, first vaporize the sample. So we vaporize the sample. Then we ionize the sample. How we ionize the sample? A vapor sample is injected at a low pressure so that it will remain in a gaseous state. And electron guns fire. This is the electron gun. So this fire the electron. So when it fired the electron, it knock out, so it will become a charge. Electric field is used to accelerate. And when we apply magnetic field, so magnetic field will deflect. So we collect at a different points. If there are more deviation, more paths are there, what it shows? It shows that it has like more isotopes, or two or more than. If there is only one path, like example, first we vaporize, so it will be in a gaseous state. Element X is in a gaseous state. Then we knock out how we knock out? By moving a fast moving electron. When it hits X, so X will remove its electron or lost its electron. It will get a positive charge and it will release 2 electrons. One which we use and the one which is knocked out. Then what we do, we use electric field to accelerate. So this electrons cannot move because like charges repel, so electrons, but this positive charge is attracted and there's a narrow passage through which this positive charge will pass. Then we use a region where we apply a magnetic field. So when this charged particle enter the magnetic field, it will deviate or it will change its direction. So if we observe two different paths, then what it shows, if two different paths are there, it shows that this element is having isotope. If there's only one path, it means that it does not have any isotope in the sample. And the point where it hits the mass to charge ratio detector. So there's a detector. On this detector, it will hit. So example, this peak strike at 50, another peak strike at 52. So what are the masses of each isotope? The first isotope has a mass of 50 and the second isotope having a mass of 52. How we conclude this? Because this is a mass to charge ratio. So if mass to charge ratio is 52 or 50, as we know the charge is +1 because our assumption we remove one electron. It might be 2 electron removed, then we'll get a different peak. But if 1 electron is removed, then the charge is always +1. So mass divided by charge, if charge is +1, so this will be multiplied, so mass will be equal to 50. Is it clear, this idea, how to find atomic mass using a mass spectrometer? The main concept is this, just vaporizing the sample. So vaporization is done, that's the first thing. Then we enter a sample using electron gun. Any question? Umar Gamal, any question? So using electric field, using electrons, we knock out the electron. So we knock out the electron from the sample. So as we knock out the electron from the sample, now the sample will become a positive charge. Then we accelerate, and then when it enters the magnetic field, it will deflect. Lighter particles will deflect more, and heavy particles will deflect less. Then using ionization, as we know, like example, say we are using titanium. So titanium atom is there, we knock out. How we'll know which value on the graph? That is the point where these, that is the point. Like example here, this point you have a detector. There's a electronic detector is there. This detector will show the graph or plot a graph for you that at which mass to charge ratio you are obtaining or getting that sample. Then we accelerate. How we accelerate? The negative electric field accelerate the positive ions and make them into a beam. You can see here, it make them into a beam. Then deflection, how we deflect? The beam of a positive ion is deflected by a strong magnetic field. The degree of deflection depends on mass to charge ratio. Smaller the ratio, larger deflection. Means, or smaller mass, more charge, so larger deflection can deviate. So this is a path for the lighter ion and this is a path for the heavy ion. And then detection, the ions reaches, how we see this, this is what we see on the screen. This is what we see on the screen. So how many isotopes are there for this magnesium? +1. How many isotopes are there? How many peaks we are obtaining? So number of peaks decide the number of the isotopes. So as there are 3 peaks, 1, 2, and 3. So it means there are 3 isotopes. But how we can find the average mass of the isotopes? So what is the formula to get the average mass of the isotope? The relative percentage abundance. What is the meaning of percentage abundance? It means how much isotope is there, or what is the percentage of isotope in the sample. So example, a peak at 24, it was 78.7%. A peak at 25, it's 10.13%. And a peak at 26, it's 11.17%. But what is the average mass of these isotopes, or relative isotopic mass? So how I can find the percentage of the isotope, so which is 78.7 multiplied by mass of the isotope. So what is the mass of isotope? That's 24. Plus the percentage of the isotope, second isotope, which is 10.313, multiplied by the mass of the isotope, which is 25. Plus the percentage of the isotope, 11.17, multiplied by the mass of the isotope, which is 26. So when you solve and divide it by the sum of the percentages, because when you add all the percentage, you will get 100. So that will be 100. So when you solve this, you will get 24.3. So that is a relative isotopic mass, or relative atomic mass of this sample. Is it clear? For example, if we have another sample, and it was giving only 1 peak, and that's all 100%, that peak is there, and that's 23 example. So what is the mass of this what is the mass of the atom? As we know, the mass to charge ratio, so mass to charge ratio is 23, and the charge, this is for, because our assumption is only 1 electron is removed, but practically sometime 2 electron, 3 electron can be removed, but our assumption is only 1 electron removed. So charge is +1, so we can find the mass of this sample. So it will be 23. And it means it has only one, and it does not have isotopes. It's a pure sample without, means does not have atoms with different atomic mass. They all have the same atomic number. But if there's another sample, and it can give two peaks, one peak it's giving at 75%, another peak is 25%. So this is 25%, 75%, sorry, and 25%. This one is at 35. This one is at 37. So now how to find, as you identify, because there are two peaks, so this shows that it contains two isotopes. So what are the two isotopes here? What is the relative, the two isotopes, isotope at 35 and isotope at 37? And what is the relative mass of the two the isotope of the isotope? So it's percentage of the isotope. So percentage is 75 multiplied by mass of the isotope, that's 35, plus percentage of the isotope, that's 37, multiplied by mass of isotope, 25, divided by the sum of the percentage. So 75 plus 25, that makes 100. So when you solve this, you will find that's equal to 35.5. So average mass of this sample is 35.5. Is it clear? Then sometime what happen, we have more peaks. When we have a molecule, we may have more peaks. Like example, say you have chlorine molecule. How chlorine exists? Chlorine exists as a molecule. So what happened in the first stage when you vaporize and then ionize? So maybe chlorine will remain as a molecule with a plus charge, or maybe the chlorine will break into two atoms and each will have a charge. So when you have an element which exists as a molecule, you may have the peaks due to atom, you may have the peaks due to molecule. So normally, like example, chlorine, there are two atoms of chlorine, one mass can be 35, another one is 37. I'll explain this part, share another link with you once this session will end. Less than a minute left, so I will share another link with you.